So in this video I want to talk a little bit about the fatty acid synthase complex, the actual enzyme itself. So we mentioned before that fatty acid synthesis, we have a condensation reaction, the first reduction, dehydration, second reduction, and this process repeats every time that we add a 2-carbon unit. And then beta oxidation, of course, is essentially the opposite. We mentioned that before. Now, what is the name of the enzyme that catalyzes fatty acid synthesis? Well, it's not just an enzyme, it's an enzyme complex. I want to stress that, and I'll get to what that means in just a moment. And of course, what is it called? Well, fatty acid synthase. That should be pretty obvious at this point. I just want to stress that so that's emphasized. Now, basically, it's a large complex, and it's specifically a dimer, and I'll kind of show you that in just a moment, or towards the end of the video. And it's got a bunch of different catalytic sites in the complex. And this is kind of how I imagine it here. I've drawn this. This is kind of how I imagine it. This is not really how it looks, and not how it's depicted. It's just like how my brain understands it. So hopefully you can understand it the way I understand it, because I felt this was much easier to understand than other diagrams and stuff. So what it's got here, I kind of drew like a pizza, and I cut it up into 8 sections with a circle section in the middle. What I've got here is that this little site in the center is the ACP, or the acyl carrier protein. And that ACP has a really important feature, which is this phosphopantothene prosthetic group. Now, that's actually the what it does is it forms a thioester bond in the same way that acetyl-CoA does. In fact, that phosphopantothene group is the same business end as that of acetyl-CoA. It's the same thing. So it can form thioester linkages like acetyl-CoA does. And what it does is it acts like what I put here. It acts like a crane. So if you imagine a crane, it kind of just shoots up out like this. This is how I imagine it again. It's carrying the substrate, and what it can do is it can kind of swing around from site to site, taking the substrate to each of these sites where a reaction can occur. A reaction can be catalyzed. So what it does is it carries the substrate from one catalytic site to the next, according to the reaction that needs to occur. Okay, so now let's get to the actual catalytic sites. So there are 3 domains, cleverly named domain 1, 2, and 3. So domain 1 I've got here written or sort of depicted in yellow. So these first 3 sites here, this AT, MT, and CE, stand for acetyltransacylase, malonyl transacylase, and condensing enzyme, respectively. And those are 3 catalytic sites in domain 1. Domain 2 is all that's in orange, and that's those there. And the domain 3 is just this TE, which is this thioesterase. Now, the details of these reactions will be in another video where I actually show you the steps. But essentially what I want you to understand is that the substrate will be carried from site to site where each of the reactions can be catalyzed. So just to give you a quick heads up, acetyltransacylase and malonyl transacylase, what they do is they basically attach the acetyl group and the malonyl group to the ACP's prosthetic group. And then instead of being called acetyl-CoA and malonyl-CoA, they'll be called acetyl-ACP and malonyl-ACP because they'll be attached to the ACP. The condensing enzyme is what actually links the acetyl group and the malonyl group. It's actually called acyl-malonyl ACP condensing enzyme. And it's called that because it connects the acyl group to the malonyl group that's coming in to make a ketoacyl group, a ketoacyl structure, which is called ketoacyl ACP. So that's the condensing enzyme is also called ketoacyl synthase for that reason. That ketoacyl group moves to the next site, which is the beta ketoacyl ACP reductase, depicted by Kr here. And then we have the DA to the ER and the TE, so on and so forth. But essentially, it kind of goes, like I said, in this direction, just like this, around the way, until and we keep adding 2 carbon units by following this path, right? So the 4 actual steps of fatty acid synthesis, or I call it beta reduction, is the condensation step, which occurs with condensing enzyme. The first reduction with this ketoacyl ACP reductase, and then the dehydratase, right? The dehydration occurs there, and then the second reduction occurs at the ER, right, with the enol ACP reductase site. So those 4 sites are going to be continually active when we keep adding those 2 carbon units. At a certain point, we'll create palmitate, right? After these rounds, after we've had enough of these rounds to yield palmitate, once palmitate is attached to the ACP, what happens is domain 3 with the thioesterase, what it does is it cleaves the thioester bond between palmitate and the ACP, and what that does is that frees up palmitate from the fatty acid synthase complex. So then, after all that has happened, you release that fatty acid into the cytosol. Okay, so how many catalytic, I shouldn't have put this here, catalytic sites in total are there on the fatty acid synthase? Well, everything with an ACE, right? ACE, condensing enzyme, or synthase, ACE. Basically, it's everything except the acyl carrier protein, the ACP. So that's 1, 2, 3, 4, 5, 6, 7. So 7. It's all except the ACP, because the ACP is not actually a catalytic site, right? It's just carrying the substrates from one site to the next. Okay, so that's pretty much it. Now, I mentioned the dimer before, so this is, like I said, this is my imagination, how I kind of see it. But how scientists kind of depict it is depicted by this dimer. So you have this unit over here and this unit over here. So of course, everything in yellow is still domain 1, everything in orange, domain 2, and the thioesterase, domain 3. So we kind of have this one kind of in, going this direction, and this one going the opposite direction, and they're connected. They can be connected here at with disulfide bonds. Okay. To be honest, I don't really know too much about this and what's going on with it. I just kind of use my imagination to understand the complex itself, which is a little bit easier for me, and I hope it's easier for you too. Anyway, I hope that video was helpful. Thank you for watching.